Hi, welcome my dear students. Now under these types of matrices, we have the next one, diagonal matrix. What do you mean by a diagonal matrix? It is a square matrix basically. Okay, if each non-diagonal elements is equal to 0, then such a square matrix is called a diagonal matrix. Okay, in a square matrix, see here in a square matrix. Okay, in a square matrix, the non-diagonal elements, the non-diagonal elements, the non-diagonal elements. See, my dear students, the non-diagonal elements are 0. Right? In a square matrix, the non-diagonal elements are 0. Then such a square matrix is called a diagonal matrix, of course. Right? How we will define this is, suppose if you have a matrix A as Aij such that this is m by n, we have here such that, okay, Aij is equal to 0. What we are having here is Aij equal to 0 when I is not equal to j, like this. Okay, when I equal to j, you will get diagonal elements, they are not 0. Right? Aij equal to 0 when I is not equal to j. Okay, such a matrix you call it as a diagonal matrix. For example, we will take something like I am having 1 2 0 0. This is a 2 by 2 diagonal matrix. First of all, it should be a square matrix. You should understand that it should be a square matrix. Okay, next one more thing we have here, something like this. I am having 1 0 0 0 2 0 0 0 3. This is also a diagonal matrix such that the non-diagonal elements will become 0. Right? This is a nice, okay, now this is what you call it as a diagonal matrix. It is basically a square matrix in which the non-diagonal elements are 0. Such a matrix you call it as a diagonal matrix. Wonderful. Next we have here a scalar matrix like this. A scalar matrix. Right? How this scalar matrix is defined as, now only we have defined a diagonal matrix. It is a square matrix in which each non-diagonal element of a square matrix is 0 such that the diagonal element is equal to a scalar. Then it is called a scalar matrix. That means, first of all, it is a diagonal matrix in which the diagonal elements all are equal to some constant. It is a diagonal matrix. It is a diagonal matrix in which the diagonal elements all are equal to the scalar k, like this. It is a diagonal matrix in which the diagonal elements all are equal to the scalar k. Then such a matrix you call it as a scalar matrix, of course. Right? You see, my dear students, let us give certain beautiful examples for this. Right? See how we are going to give this example. For example, we have, as I told you, that here a scalar matrix means here I am giving the examples. For example, I am having 2 0 0 2. This is a scalar matrix. Here the principal diagonal elements all are having as 2, like this. Right? Fine here. And also we can say one more thing, we can take that 4 0 0 0 4 0 0 0 4, like this. This is also one thing. That means how we will define A of Aij, this such that this is equal to what we will say, the elements Aij equal to 0. If I is not equal to j, Aij is equal to some scalar k when I equal to j, like this. Right? This is an example of a scalar matrix. Like now we understood diagonal matrix is a square matrix in which the principal diagonal elements are not 0. Scalar matrix is a diagonal matrix in which the diagonal elements all are equal to one scalar, like that. Next we have one more thing, what we call the unit matrix or the identity matrix. A unit matrix or identity matrix, how it is defined is, it is a scalar matrix. Basically it is a scalar matrix. Basically we defined what is scalar matrix. It is a scalar matrix in which all the principal diagonal elements, in which all the principal diagonal elements, principal diagonal elements, in which the principal diagonal elements are equal to 1, and non-diagonal elements, okay, equal to 0. That already answered in scalar matrix. That means precisely how we will define. This is something like 1 0 0 1. Okay, yeah, I. This is I 2 2. Like that means it is a square matrix. Okay, of order 2 by 2, and I 3 by 3 unit matrix. What we have here, 1 0 0 0 1 0 0 0 1, like this. Okay, this is precisely we define it as Aij. Okay, the matrix A is Aij such that Aij is equal to 0 when I is not equal to j, and Aii is equal to 1 when I equal to j. In this way, you will be defining beautifully about this diagonal, okay, and unit matrix, of course, right? This is what the way how we will define this unit matrix, my dear students. Next, we have one more thing, what we call it as upper triangular matrix, right? Upper triangular matrix. Upper triangular matrix. Okay, my dear students, you see how we are going to do this definition upper triangular matrix. Like a square matrix is said to be upper triangular if right Aij is equal to 0 for all I greater than j. Okay, a square matrix. This is also a square matrix. A square matrix, right? A square matrix A is equal to Aij. Okay, yeah, we have here a square matrix. So A is equal to Aij. When you call is said to be upper triangular, of course. This is said to be upper triangular. This is said to be upper triangular. When we will say if it is a upper triangular means, okay, Aij is equal to 0. If Aij is equal to 0, if I greater than j, like this, equal to 0 if I greater than j. This is what we call upper triangular matrix. For example, we have here something like this, right? What we have here is something we can take 1 2 3 0 4 5 0 0 6, like this. Here you see, my dear students, these elements we have here, this is what A21 is 0, A21, A22, A23, A31, A32, they all become 0. That's what we have here, A21 equal to 0, where 2 is greater than 1, A31 equal to 0, 3 is greater than 1, A32 equal to 0, where 3 is greater than 2, like this. In this way, you will be defining the upper triangular matrix, and it is very, very important, right? See, my dear students, next we have lower triangular matrix. A square matrix Aij, is said to be lower triangular matrix if Aij equal to 0, if I is less than j, right? For example, we will take here, okay, if I take, for example, A is equal to, right, I am having here lower triangular matrix 1 0 2 3, like this. Here you see we have this element. This is actually here A11. This is A12. Here A12 equal to 0 because 1 less than 2, like this. Right? This is the way how you will define lower triangular matrix. You will have lower triangular elements like this, of course. Next, one more thing we define like suppose I have here 1 0 0 2 1 3 3 1. Okay, 2 1 0 3 1 5 something. This is also here. You see, my dear students, here A11, A12 equal to 0, and another one A23, A13 equal to 0. Here 1 is less than 2, 1 less than 3, like this. Similarly, here you have here A23 is also equal to 0 because 2 is less than 3. This is what you call, see, a lower triangular matrix, right? This is the way how you will define lower triangular matrix. Next we have a triangular matrix. Now the 12th one, we have a triangular matrix. You see, my dear students, a triangular matrix. A triangular matrix. How you define a triangular matrix? A triangular matrix, a matrix, a square matrix A is said to be triangular matrix if it is either upper triangular or lower triangular. Like either see, A is either upper triangular or lower triangular. Okay, then A is called triangular matrix. This is called as a triangular matrix, like this, right? Either it should be upper triangular or lower triangular. Then such a matrix you call it as triangular matrix. Okay, my dear students, in this way you will be defining this upper triangular, lower triangular, and triangular matrix. See here, two matrices A and B. Two matrices A and B are said to be equal. Either A and B have same order, right? Their order is either same and their corresponding elements are equal. Then you will say that those two matrices are equal matrices, right? Two matrices A and B, they should have the same order. We know that what you mean by order of the matrix. That means number of rows by number of columns. If suppose we are having here A is equal to B, okay, if this is 2 by 3 matrix means this is also supposed to be 2 by 3 matrix. And also, okay, you are having A as 2 by 3 means 2 rows. Okay, A11, A12, A21, A22, A31. Okay, fine here, of course. What we have here, like this 2 by 3, and this is what A13, A23. This is what 2 by 3. This is equal to, okay, this is also 2 by 3. That means what we are going to have, B11, B12, B13, B21, B22, B23, like this. Okay, number 1 is this, number 2 is this. Their corresponding elements are equal. That means A11 is equal to B11, A12 is equal to B12, A13 is equal to B13, like this. And similarly, you have here A21 is equal to B21, A22 equal to B22, A23 is equal to B23. Their corresponding elements are all equal. Then we will say that those two matrices are equal matrices. Of course, for example, one more example we will take here. Of course, okay, one example. I am having matrix A is equal to X, Y, Z, W, and this is equal to 1, 2, 3, 4. Then we can say that once if they are equal matrices, from that what we can say, X equal to 1, Y equal to 2, Z equal to 3, W equal to 4. In this way, the equal matrices are defined. Now, based on equality of matrices, we have a nice problem. If this matrix 2 by 2 is equal to this, find X, Y, Z, W. How we are going to see? Once they are equal, my dear students, let us equate their corresponding elements. This is a 2 by 2, 2 by 2. X minus Y equal to minus 1. We have here. And another one, we have 2x minus y is equal to 0, like this. You just minus plus like this. And minus x is equal to here minus 1. X is equal to 1. Beautifully we have got x equal to 1 here. And also we know that x minus y equal to minus 1. Therefore 1 minus y is equal to minus 1. 1 plus 1 is equal to y. We have here like this. Y is equal to 2, like this. X equal to 1 and y equal to 2. And by comparing these two also, 2x plus z is equal to 5, like this. 2 into 1 plus z is equal to 5. Z equal to 5 minus 2. That is 3. Now 3z plus w is equal to 13, like this. 3 into 3 plus w equal to 13. W equal to 13 minus 9. That is 4. Therefore w equal to 4. X is 1, y is 2, z is 3, w is 4. In this beautiful way we have got this particular problem, my dear students, right? Okay, equality of matrices. In this way we will be getting this particular problem, right? Now see, my dear students, we have another problem. A matrix has 12 elements. What are the possible orders it can have? The total elements are 12 elements. The possible orders, 1 we can say that 12 by 1, 12 rows 1 column, 1 by 12, 1 row 12 column, 2 by 6 we may have, 6 by 2 we may have, 2 rows 6 columns, 6 rows 2 columns, 3 by 4 may have, 4 by 3 we may have, right? These are the different possible orders we can have. 1 by 12, 12 by 1, 2 by 6, 6 by 2, 3 by 4 and 4 by 3. These are the different types of possible orders can be possible. This problem can be done very beautifully like this. Next we have one more thing. Construct a triangle 2 by 3 matrix. Right, a 2 by 2 matrix otherwise. Okay, construct a 2 by 2 matrix whose elements are given by, see here, construct a 2 by 2 matrix, 2 by 2 matrix. Aij is given by the relation Aij is given by, see here, what is the relation? I plus 2j whole square by 2. I plus 2j whole square by 2, like this, right? You see, my dear students, how we will do this is, first of all, it is a 2 by 2 matrix. That means A11, A12, A21, A22, like this, right, my dear students? That's nice. Now we will do that A11. A11 is nothing but I is 1 and j is 1. That's why 1 plus 2 into 1 whole by 2, I plus 2j whole square by 2, like this. That is 3 square, 9 by 2, like this. A12, that is 1 plus 2 into 2 whole square by 2, like this. 5, that means 25 by 2, like this. A21, we have here A21. A21 is nothing but 2 plus 2 into 1 whole square, right? A21, I plus 2j. I is 2 plus 2 into j is 1 by 2, right? That is nothing but 16 by 2, 8. Next, A22 we have here like this. That is nothing but 2 plus 2 into 2, 4 whole square by 2. 36 by 2, like this. Therefore, this matrix A is nothing but, you have here 9 by 2, 25 by 2, 8, 36 by 2. This is the way how you will define and construct the 2 by 2 triangle matrix by the given rule Aij equal to I plus 2j whole square by 2. In this beautiful way, we will be constructing this particular matrix, right, my dear students? Wonderfully, we will do one more problem like this, and right, that's very nice. So see, we have another beautiful problem. The problem is here, they given construct a 2 by 3 matrix Aij whose elements are given by the rule I minus j by I plus j. Here you see, my dear students, a 2 by 3 matrix means 2 rows, 3 columns, A11, A12, A13. And this is the first row. Second row is A21, A22, A23. This is the second row. See here how we are going to do now. A11 is nothing but I minus j. 1 minus 1 by 1 plus 1. That is 0 by 2. That is 0. A12. This is nothing but 1 minus 2 by 1 plus 2. Minus 1 by 3. A13. 1 minus 3 by 1 plus 3. That is minus 2 by 4. That is minus 1 by 2. Like this. A21. 2 minus 1 by 2 plus 1. 1 by 3. Like this. A22. 2 minus 2 by 2 plus 2. 0 by 4. That is 0. Like this. Right? And we have the last one, A23. That is nothing but 2 minus 3 by 2 plus 3. Minus 1 by 5, like this. Therefore, this matrix A is equal to, we have nicely constructed this matrix, my dear students. A11 we have got 0, and A12 we have got minus 1 by 3. A13 is minus 1 by 2. A21 is 1 by 3. A22 is 0. A23 is minus 1 by 5. In this beautiful way we have constructed, we have to just follow the rule. Here the first one is I and the second one is J. Okay, I is J. In this way we will be calculating. And also one more thing, this is a 2 by 3 matrix means 2 rows. two horizontal ones and three vertical ones. That's why it is what we call a 2 by 3 matrix. Okay, my dear students, in this way we will be doing these beautiful problems.